This is the Earth Science Classroom. Welcome back to the video. This is the rock cycle part 7, and we're going to look at how things connect beyond this basic schematic. So this diagram is showing you the components of the rock cycle, the main ones. So magma and lava. You got igneous rock. You got sediment. You got sedimentary rock. And the last but not least, the metamorphic rock. So you have the three types of rock. And you have different processes that are associated with forming each type of rock. And you can go into various other areas of geology and geomorphology and minerals and volcanology, earthquakes, above ground processes, below ground. So this is a very good starting point, the foundation of geology. So again, this is part 7. So the previous parts, if you want to check them out on the channel, the first part really I just do a little overview of how we build our rock cycle. And then part 2 is kind of like magma and lava. Part 3 is more like the process and formation of igneous rocks. 4 is the sediment, weather and erosion. And 5 is, the process of metamorphism, and 6 is how to get back to magma. So sedimentary rock is included in video 4. Now, there's more to this as well. So most times I've seen this in textbooks or in activities online is that teacher would just do this simple cycle. Now, in reality, it's a lot more complex, and different timescales, different environments can change what happens, but students need to understand how each one is formed. So we look at magma, for example, right? So anything that is involved with magma. So how to create magma. So anything going to, if you get a igneous rock and you put an arrow to magma and lava, so you're saying that this igneous rock, which is solid, is now being transferred into the liquid form, which is magma. Now you discuss lava when it comes to the surface, but magma, so anything with magma would be melting. And you can go into more detail on how this happens. Now I go through this in video 5 and video 6. Now, so this arrow here will be melting. Now you can also see this, but really, I mean, you do get some melting of sedimentary rock if in certain conditions. So you could also put an arrow from sedimentary rock to melting. Now the 99% of the movement of the rock goes from sedimentary down to metamorphic through metamorphism, through burial, but there is some very scarce times when sedimentary rock could be exposed to high enough temperatures without the pressure, and it could literally just turn back into magma. So we can discuss this. So sediment is hard. Sediment to try and get to magma is tough, but again, it could happen. So we can have melting through there. So anything to magma is melting, but the general course of action is sediment into sedimentary rock through liquefaction. So to get igneous rock, you need to have magma or lava. So you can't just do this. You can't do that arrow from sedimentary rock to igneous, because you need to have that process of having magma that's going to cool and go through the processes to form igneous rock. So be careful there. However, we can form sediment through the process of weather and erosion, and you can also discuss depositional environments and transportation. But you can have metamorphic rock turn into sediment. Now, obviously, you need to have uplift in addition to weather and erosion, because this obviously occurs on the surface. And depending on where the metamorphic rock is in terms of depth, there's some serious uplift, which is generally tectonic. So anything to do with sediment would be weather and erosion and uplift, especially if it's an intrusive igneous rock. And sedimentary rock can turn back into sediments, obviously the same way. But this is going to be a faster process because it's already mostly on the surface or very shallow depths on the in the crust. So to make sedimentary rock, you need to have sediments. There is no way around it. You can't just go from magma directly to sediments because it needs to go through the process of creating sediments. So there has to be some pre-existing source rock that is broken down with an erosion uplift to form sediments in order to go through lithification and end up as a sedimentary rock. Now, last but not least, metamorphic rock, which is formed from heat and pressure and depth and metamorphism, that can occur through different ways. Now, you can't just get magma and go to this way because magma can't do that. Magma only cools and goes this direction towards igneous rock. So you can't do that. However, once you have a rock in play or formed, you can then add the depth, temperature, and pressure and burial and go through metamorphism, different grades, and form metamorphic rocks. So again, there's certain directions and pathways that these materials work in to form each rock type, and that's important to understand because then we go into geomorphology, stratigraphy, and try and figure out the layers of the rocks and geologic history with the processes involved. You need to understand this foundational basics of the rock cycle and how it is complex. And you can also look at different times, areas, and look at situations as well where these things may occur. That's not just the general single one route or one route cycle that is usually presented in the classroom. So students somewhat get confused when you add in other ways that this works. This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel. And don't forget to subscribe. Thank you again.